Well, hi, good morning. Thanks so much for joining me here in my shop. It's June 12th and it's day one on this console receiver. Now, how did I get this on my bench? I've got a little bit of a slideshow of how it got from the console to my bench here. We're going to take a look at that. Okay, so there's the console it's come out of. It's probably a early, like a very late 1960s console, I would guess. Something like that. The console's in really good shape. The speaker grills here look fantastic. Something odd has happened to the front here, but I won't go into what all those chips are from. Let's take a peek inside. So fairly typical of a console like this. Looks like my picture's upside down, but that's okay. Got the radio, AM, FM radio, and a record player here. It's a Gerard record player. There's a close-up. It's got all the speeds from 16 to 78. Manual, auto. Very, very common record player. Auto Slim. Probably this should have been removed when the record player was sold, but you know, this information here. Anyway. So here's the back of the console. Lots of information written on the back. Ask for Viking tubes. Now, I don't know if I've ever had a vacuum tube that said Viking on it. Viking was the brand name for a large retail operation called Eaton's, which was really kind of like almost like a part of Canada for a long time. But it's long out of business now. So all the Viking things were really just Eaton's brand. Who actually made this? Maybe we'll find out. Now it's got this great big hole in the back, a huge hole in the back, which is kind of odd. Connected to I and, well, why wouldn't you? Why I? Like, why didn't they put an A there for antenna? Okay, next picture here. So you can plug in some external speakers. It has the switches right here. Internal, external, or external. There's the inspection tag. It looks like, oh, there's an inspection stamp there. He must have done it with some kind of disappearing ink. Oh my gosh, is that the date? That's the date that this tag was created. 1954, I think. I think that's what that date is. Approved power-operated phonograph. Okay. Here by the Eaton, a Viking brand by the T. Eaton Company. There's the model, RCS633. Licensed by the Canadian Radio Patents. A little out of focus there, but that's the big handhole up above, and here it says circuit breaker inside, push to reset. So what they're inviting you to do is reach your hand, what's going on here? Reach your hand into the back of this thing blindly and try to find a little tiny switch. I'll show you the switch when we get around to looking at the unit. So now here's how the unit is in the radio. It's an upwards facing stereo, so it's kind of put on its side here. Taking these in and out needs to be done very carefully. These things are easily dropped in the process, and they're mounted in various ways, but usually there's some quick release or easy release way they've been put in. Let's take a look at this one. I think I just reached in with the camera and snapped some photos kind of blindly. That's the that would be for a tape recorder, I'm pretty sure. And this is the phono input up here. Don't know what these are. That's a lot of inputs. Here's the speakers. Nothing really to write home about, but far from being terrible. We've got a mid-range tweeter up here and a fairly large woofer down here. I wish it was a little bit bigger. But considering the record player that's in here, you wouldn't want to reproduce too much bass, too much really low bass. So that could be why they restricted it to this size. It's also a question of what the console looks like in the front and all that. So there's a capacitor up here, and that's trying to block some of the lower frequencies from entering the high frequency speaker. Same thing on the other side, of course. Oh, there is the other side. You can see the record player hanging up above. So these are me taking photos of plugs and wires. I didn't really know what was in there. I couldn't really see. So you can see these are the speaker plugs, and they're plugs. They're not just wires. Oh, we should go back. Do you think you could, you're reaching your hand in to push the reset button on this stereo. You'd be reaching it right to the front. This is the front now. So by now, your elbow is inside this thing. And you're trying to find this little red button, which is impossible to see. Good luck. Good luck sticking your fingers in there and finding that. They really should have put, no user serviceable parts. Yeah. So we're looking, of course, at the top of the stereo just before I pull the knobs off of it. So here what I've done is I've pulled the knobs off and I'm lifting this plate off, because often the screws that hold in the unit are located under here. So you got to get this grill off. There's a sheet of plastic here. You can kind of see it slipped a little bit. You can see in the holes here. A sheet of clear plastic that's protecting the top of this from finger wear, by turning the knobs and wearing off the words in that. That's a little bit unusual. Good move. Looks just like new underneath there. Well, I'm looking down for those magic screws, but there aren't any. Usually you would find screws, like here or here, but there aren't any. There aren't any in here. There's this thing, though. What's that doing there? And where's the bar of gold I'm always looking for? Something worth taking note of, too, in this receiver. You see the string here that's running along here. That's going to pull the pointer up and down and turn the capacitor when you tune it. The string uses, I think this is the volume control knob, as one of its pulleys, if you like. I shouldn't really say pulleys, but a post that it slides across. Just a little odd. There's another shot. What I'm trying to show here are these screws. So I spotted these screws and thought, wow, okay, if I take these screws out, then the radio's going to come out. But I looked a little closer, and you can see that this is actually screwing a small metal bracket, this part here. Screwing it into the cabinet. This is part of the radio here. And it's slid up in behind. So this is a bracket. You slide this upwards into it. There's no screws up here to take out. And the only reason I didn't do it wrong is because this screw would be really tough to take out if this were in here. And that was the hint. That was the first hint that probably this screw doesn't get taken out. Lucky me. Those are the mistakes. Didn't make it. Here's a close-up of how that string comes across here on the knob. Okay, a little out of focus. You notice on the bottom there's this document. This document is pasted solidly to the bottom here. I think I got a shot of it coming. I'm just trying to take shots, in as far as I can reach in here. There's that circuit breaker button there. Look, there's an outlet here, but there's nothing plugged into it. How's that record player get its power? And I'm trying to get a shot of all these before I pull plugs out. You see they're all empty except for these two, and these are the phono plugs coming in. I want to make sure I get shots of this stuff because, although I might think at the time I can remember stuff, no. No, I won't remember this stuff. So unfortunately this is way out of focus, but this sheet still exists out there in the console. I can't lift it off the bottom. You can see it's gotten water or some kind of damage has come in through the bottom here, but still all legible. And this is all the instructions for assembling the console, putting all the plugs into the right sockets and all that kind of stuff. That's what this is for. No reason really to take it out of the console. I don't think there's really a schematic there. And there it is, finally taken out. I had to take out 2 support screws that were down low here. Maybe my photos are out of order. Did I not take a photo of it? Let me go back one. Let me go back another. Yeah, back another. So here we are. So we can see this screw is holding this in solidly, but you can't get this guy out without removing that screw entirely. So if you remove the screw entirely, excuse me, there's nothing holding this up anymore. So you have to hold it with your hand. So you got to reach in with one hand, hold this thing, take the screw out, and then while holding this thing up, do the other screw. There's another one on the other side. Take it right out. What they've done is they have 2 more screws. Now I think this is one of them. I'm sorry, my photo's not so good. I think this is one of them here. There's another one just near the other, I don't know what it calls, support screw. So the way it works in this is they cleverly put 2 more screws in just below the chassis here. Neither of them appear to be doing much. Excuse me, they were screwed down tight, just catching the edge here. I backed these 2 screws up, a turn or 2, so they were no longer gripping this. And they became a rest point. So you could take this screw out, and the thing would just rest on these screws. Hey, that was a great idea. Except it didn't, and it came down. It came down, what, about ½ an inch or a ¼ inch or something like that, but it wasn't enough to clear the upper bracket. So I still couldn't get it out. So I ended up holding the thing with my hand and taking these last 2 screws out. Still a bit of a risky deal. You don't know how heavy these things are until they're in your hand. And can we go back another photo? Maybe another, and another. Okay, in this photo, I'm going forward actually. You see the big power supply transformer. There's a lot of weight in here. Maybe half the weight of this whole thing is in this. So this is what I grab onto. This is a good solid thing, bolted hard to the chassis. Always a great, get your hand around it really good. And they're kind of rugged. There's nothing fragile. So this is a great place to hold onto it. The tendency is to try to grab the sides. That's good too, but grab this and you've got the weight right in your hand. You get major control over everything. So things don't rock and tip and roll out of your hand, fall on the bottom here, which it didn't happen. And I think that's it for the slides. And here we are again, back here looking at it on my bench. Now, the reason I took this out is because I suspect it's got capacitors in it that need to be changed. I hadn't even looked yet. Amazing. I brought this in here and didn't take a peek. This is really worth having. It's modern. It's pretty modern. It's got tubes in it, but it's a modern tube receiver. I don't mean modern in the sense that it just made it, but it's got some of the final tube stuff. Tube technology. Can I call it that? Let's take a look underneath and find out what we got here. Oh, well. Okay. Well, I believe the owner told me that the radio was working fairly well. And I may be kicking myself now for even taking it out and bringing it in here. It's really the record player that's a concern, but, while the console's here, I might as well have a look at it. So, first thing I see is, where's all those wax capacitors? There aren't any. They've put in all these disc capacitors. So this is the era where they finally stopped using paper wax capacitors and moved on. And there may still be some weaker capacitors in here. These guys look a little suspicious. They've got the word Hunts written on them. Hunts capacitors, not of this type, but of other types. They're really molded Hunts capacitors are bad actors. So, but we will take a close look through here with the close-up camera and just make sure everything is in order before we try operating this. Excuse me. Switch cameras here. Okay, we'll just start in the bottom corner. Start working our way up. So, well, that's a little odd. The on-off switch, is it a rotator? Oh, I'm rotating it. Is it a pull on? Maybe I push it. Ha, okay. Push pull. Let me hold my hand a little stiller here so we can, or a little more still. One second here. Put a little more light on the topic. There's a little blob at the end of the shaft. There's what's caught in the fork. There's a fork right up there. Wow. Okay, that's pretty unusual for how they're doing the switch. Sounds fine, seems to work fine. I bet you it is fine. Ooh, lovely shiny solder. Usually I'm looking at such dusty old things. Now, consoles, because they're usually inside a pretty good box. That's another Hunts. Now there's a molded one, so we'll get rid of that. Pop this guy out and check them, and then make a judgment about others that might be in here, if there are others. Hunts, eh? I wonder if they were the discount manufacturer of the day. Here's these electrolytic ones. They don't look swollen or anything, but they say Hunts on them. Yeah, I don't think it's swollen at all. Okay, I don't want to miss anything here. Let me go down. Oh, talking about swollen. Does that look swollen? Is that my imagination? Does that look like a fat resistor? Well, it doesn't look very healthy. Look at that. It's like a molded resistor. It's got the two halves, welded together there. Plastic welding. Well, that doesn't look good to me. You have to test it, or just replace it. It's just a little resistor. Are any others doing that kind of thing? It's really interesting. When I was working at the power company, I went into lots of manholes inspecting cables. And cables, they look like this kind of, well, they're not brown in color, and they're all lead on the outside. But the splice, the relative size of the splice is about like this resistor sitting here with the wires. So in the case of the cable, in the manhole, the cable, which would be the wire there, is about the size of your forearm. And the joint would be, I'd have a hard time putting it on my bench. It's that big. Hard time picking it up too, extremely heavy. But when you go into the manhole, one of the inspection things I did very quickly was I just looked at the joint to see if it was swollen, and I discovered that your eye can pick up a a line that's not straight very easily. Like, look at that, that's straight, right? Look at that, that's straight. Okay, look at that, that's not straight, that's definitely swollen. I'm back doing what I used to do. So a swollen joint in the electrical system, swollen splice, meant that oil in the cable was being pumped into the splice and was blowing it up like a balloon. But it's not a balloon, it's metal. So you can only stretch it so far before the metal will split. And once it's split, now you have a hole in the metal cover. There's a crack in this resistor too. There's a hole in the metal cover of this cable. This is in a manhole under the streets. That water's going to go in there, and that cable's going to blow sky high sometime later. I don't know if I've ever seen a swollen resistor before like that. I just haven't been looking close enough. So I don't see anything else like it, and I don't imagine to see anything else like it. Just trying to lay eyes on everything here. There may be not so much a defective component worth seeing, but there may be other things worth seeing now. So here's this green thing in this plastic tube. What are these? These probably capacitors then. Made, British made, British made. Proudly declaring that. So I think the value is just up around the corner here. But hold on, can we see a value on it somewhere? British made. No. How come I've got so many British parts in this receiver? Now, what has happened there? That the plastic tube has melted back in vicinity to this resistor. So now that's a higher wattage resistor. Looks like its value is looks like orange, black, orange. Maybe 10K, I think. This guy's probably getting warm, and he's literally melted that. There's another capacitor here. This is a another big one, probably a good one to replace. Made in Canada this time. A Mallory. It's generally capacitors of this type you'd want to consider replacing. It looks great though. Doesn't look bad at all. There's that resistor again. So this is the rectifier at just two of them. A rectifier for converting the incoming power to DC. So somewhere around here we should find some fat capacitors. Oh, they're up on top, I'm sure. You know, this is a bit of an unusual one too, made in Canada. It's unusual because this is a very, very strongly built capacitor. And is it right across the power line? Or is it doing something like that? Well, here's the power coming in, right here. So we're pretty close to that. That's probably the circuit breaker we're looking at, the backside of it. That's probably the alternative. Ooh. Oh, it looks like the speaker plugs. I'll just get quiet for a while and carry on. So yeah, look, right where the power is coming in, this white capacitor is there. So this is probably the guy whose job it is to sit across the 120 volt power line and grab all the RF interference that might be coming. A resistor here too, which is a little. So this also could be something a little different. This could be the capacitor and a resistor combination. You know, it's 470K. So this really, what this really is a resistor capacitor connection to the chassis. So I think we'd find this terminal is actually going down to the chassis. Yep, there it is down there. And it's soldered too. So this is where they've made a chassis connection. This may be the only thing connected to the chassis. Let's go for a quick hunt on chassis solder connections. Can we find anything else soldered on the chassis? Don't jump to conclusions now. I'm not sure what that is. Something up above. It's not quite what I'm looking for. I'm looking for a real wiry connection to a terminal on the chassis. Here's one. Okay. So that is probably this terminal, which is missing on the socket because it's been laid flat. It's interesting, eh? That almost certainly is one of the heaters. So almost certainly they're running the heater power, one leg of it, through the chassis. So we'll probably find one wire winding its way through here, feeding the 6 volts to all the tubes. And instead of another wire going back, they just tied it down to the chassis. Now there is a power supply, a big transformer in here. These aren't in series. No, they wouldn't put all these in series. Would they? I mean, this is the suggestion of a hot chassis here. This way of doing things, but not necessarily. Okay, so I'm not too sure, but interesting stuff to look at. Everything is in good shape, though. I mean, that's really what we're interested in here. Okay, moving up now into the, this was kind of power supply and audio circuits. Now we're getting into the radio. If I just pull back a bit, you can see it has its own box in here. I know it's out of focus, but I'm sure you can figure it out. So we'll start on the bottom here. So now we're in the radio. So parts everywhere in here. This is not a neat and tidy job. The parts are going every which way in here. Wow, and they're, like you can see as I move the camera, there's a depth to all this too. But probably not much has to be done, if anything, up in here. Bottom of the tube sockets. So they've taken the terminal here on this, what I assume is one of the IF cans. We didn't really look at the top very carefully. We should have. There's many IF cans up there. They've just made the connection to the terminal on the tube. Save a piece of wire. That's what they did there. Oh, so here's something going to the chassis. Another thing going to the chassis. There's that wireless connection made there again. Yes, there's a lot of IF cans in this radio, and I've never really spent too much time, didn't spend any time looking at them. Well, not another swollen resistor. I wonder what happened to that one resistor. I'm going to take a resistance measurement on it right now. Okay, let's have the wagers. What do you wager? Oh, must have banged my camera there. So it does look like orange, black, orange. So orange, black, orange would be 30K, 30K. 30K, right? Let's see if that's really true. Whoops. I like to wake up my instruments a little bit in the morning. I'm reading it in the circuit here, which is somewhat invalid, but it can't read higher, it can only read lower. Well, that sure says something, doesn't it? So we're watching a capacitor charge up, and this resistor is way out. So let's nip it out. I'm going to do it right now. I won't even pay attention to anything else. I'll just get this over and done with. Okay, I'm leaving a little bit of tidbit of wire here, so I reduce the chance of me making a mistake. You know, we can test it right now, because as I like this is a distorted resistor, so as I cut it out, I'm mechanically working it. I'm further distorting it. Maybe the readings are going to be affected. Let's try it like this on the 2 million scale. It's right open. It's totally open. Found that with eyeballs. Wow, this is the second thing the last radio I was working on. I found this amazing piece of wire. Actually, I'm going to keep it. That was causing problems in that radio, and I won't go into the length of it. You may have watched that video, but wow, talk about luck the more I think about it. So definitely swollen. Let's try it with clip leads here. Still had the last customer on the line there. Okay, so there's no question on this reading. So it wants to show something. Kind of settled in there and then took off again. So this could be so sensitive. I am going to squeeze it with a pair of pliers. And we're going to see what happens here. It's jumping all over the place. Squeezing. Huh. See that jump? Wow. Now wiggle the thing here. Oh, it's kind of settled in at 5. Oh, that'd be 5 megohms now. Yeah, it's kind of settled in. Oh, if I squeeze it. Wow. Okay. I'll head to the garbage bin. Now, was it really what I thought it was? I think we can rely on those colors for sure. Or is it orange, orange, brown? Uh-oh. Is that orange, black, orange? Uh-oh. Did I misread it? Huh. Wow. Yeah, well, you know, just at a glance, it looks like orange, orange, brown. 33. Oh my gosh, that's a far cry from orange, black, orange. So the brown is real. I think there's a brown band there. Oh my gosh. This is tremendously different values here. It's either 330 ohms or 30K, but the brown. We have to find this on the schematic. I got myself into a jackpot here. I cut a part out and I'm not ready to replace it directly. Did I mention that if this is the first videos of mine you're watching essentially live, although it's recorded, and I'm doing this live and I don't edit very much. I should edit more. So I'm going to put some clip leads on here so I don't forget where this resistor came from. Oh, this is an easy resistor to spot on the schematic because it's right on the filter capacitor, right between terminals, so this will be easy to find and verify for sure. So another one over here, it's orange, orange, brown. I bet you that is orange, orange, brown. 330. Okay, but we can't be guessing. That range is too big to just take it's one or the other. I gotta know which one it is. Oh, you're looking at the wrong camera. Yeah, did I say something about this is live and mistakes get made? I'm so sorry about that. Oh my gosh, how much of that did you miss? Ever since I took the close-up on here. So I don't think you missed too much. Okay. Let's look at the top and consider what's going on, and then I'm gonna have to get a schematic going. Just let that go under there. There's a busy little radio here. See, the tuning capacitor, antenna input, and the basic flow is this way, of course. This is a 6AL5, I'm sure. 6AL5. This is one of the detectors down at this end. This could be detector for AM and FM. We don't know right now. So we have a number of IF cans here, and then we have this last one, which is probably the FM detector, a part of the FM detector. Why this up here? Like why not 2, 2, 2 all the way? I don't know. A lot of these radios, they incorporate 2 coils into each of these cans. I mean, I say 4 coils, 2 transformers into each of these cans. one for AM running around 450 kilohertz and one for FM running around 10.7 megahertz. And so in a radio like that, you don't see these, you just see a single string and then one loner out here, the FM detector. Why there's another set here? It could be it's AM down here and FM down here. I don't know. I don't know what they're doing. They like to run both IFs through the same tubes, so you can, save a lot of parts. So you would save these. So you would just and then well, there's a lot of tubes here too. Usually most of these radios have one IF stage of amplification. This one may have two. So you probably have an RF amplifier here. Oh wait a minute, this is an FM radio. Where's the FM tube? So maybe this is the FM tube. All this will come clear once we start looking at information about this radio. Now if we look at the output side of it, so I'm just, this is a process of getting familiar. Nothing has to be so certain right now. Just trying to lay eyes on lots of stuff. So as I go forward, I have some base to operate from, so to speak. Look at that funnel here. What's this? That's an unusual thing. What's it doing there? This could be, I'm going to take a wild guess, this is the multiplex output. Wait a minute. You got two tubes here. Two output transformers. Of course it's a stereo unit. It's got two sets of speakers. Is it FM stereo? Does it do FM stereo? How could we find that out? To run out and look at the panel and see if there isn't a switch to switch it into stereo. It's got to be stereo. This is way too new to not be stereo. Maybe a stereo indicator light? I don't think I saw such a thing anywhere. Well, I'd be stunned if it's not stereo. So that being the case, then there has to be a demodulator in here somewhere too. I don't think there's enough stuff here for that. I think this might be a multiplex output, and you would buy an additional unit to develop the actual stereo. And then this is probably, if you have the multiplexer, you probably take the composite signal here, and the stereo signal is probably going in here if you had that unit. There's no stereo unit here. I think I saw something on the back of the I think I saw something about that written on the back of the cabinet back. So that's probably what's going on here. The two capacitors in the power supply and the big power supply transformer. So you can see how many wires are coming out of the transformer. They're all hidden in back here. Yeah, a little hard to see, for sure. Whoop, whoop, whoop. What is it? Okay, so what I'm going to turn my attention to, I think, finding a schematic, figuring out that resistor. The one part. Now, that part may have been wrecking this thing. I don't know. It's in the power supply. Hard to say what a little couple hundred ohm resistor is doing in the power supply that would wreck this, but with it being open, it certainly wasn't doing what it was supposed to do. So, maybe that's the big winner. Maybe that's the big win already on this. Okay, I'm off to try to find a schematic for it. And as luck would have it, yes, I found the entire service manual at one of my favorite sites here, Pacific TV. See, at pacifictv.ca. These guys are located out on in British Columbia, I think, on the west coast of Canada. And they maintain an extensive collection of Canadian schematics and manuals and that, all free for the taking. So thank you very much, Pacific TV. So here we are. Let's go through it. Viking service information parts lists for a number of models. 8 tube.
Is that so? 1, 2, 3, 4, 5, 6, 7, 8.
8 tubes. Yeah, they're not lying. 8 tube AM FM stereo. Stereo radio phonograph combination console. Is that what you officially call these things? When writing for service information, all information leaflet. June 63. So that gives you an idea of the date. I thought it was late 60s. It's actually kind of early 60s. Changes covered by bulletin. Level balance control dual element friction clutch type. What? Designed to provide bass and treble boost as follows. So in a lesser device, the tone control amounts to a treble cut. You're just getting rid of the treble. You knock down the treble and turn up the volume. You're in effect raising the bass a little bit. So that's how that simple treble cut works. But most engineers want to get way beyond that, especially with a console like this. And they want to be able to have a two-tone controls, a bass and a treble, that are neutral in the middle and will cut if you turn to the left, but will boost if you go to the right. And that's tricky. The boost part is a little tricky. So here they're actually detailing out how much boost or how much reduction you get. Oh, lift. What frequency? Wow. Bass tone control dual element designed to provide 7 dB cut, cover sound spectrum. The other thing I like about these consoles is these are engineers' dreams, because there's no limit on space. They don't have to try to jam the radio into a little tiny box to sit on a shelf. They have all the room in the world to do whatever they want, and they do it. The chassis is bigger than it would need to be. Parts are separated more than they might need to be, and the engineers have a lot of fun with all this kind of stuff. Because I'm sure, I've never talked to one, I've never known one, never been one, but I have to guess there are certain things in designing these radios that are the mark of an excellent design engineer. And a lot of it has to do with the tone coming out of the speaker and the way it sounds, of course. Look at all this effort they put into this kind of stuff. Okay, stop talking and keep moving. Sensitivity numbers. Lots of information provided here. Lots of information. Don't exactly know what they're saying here. 10 kilocycle bandwidth at 2x down. 2 times down. 10 times down. Not exactly sure what they're saying here. Amplifier. Frequency response on the amplifier itself. 30 to 20. 5 watts. It sounds like nothing, but this is 5 honest watts, not 5 manufactured watts like you would. Talking about 5 watts. I've been doing a little ham radio work the last week or so using FT8. If you're a ham radio operator, you know what I'm talking about. And I'm reaching around the world as much as you can on 4 watts of power on a lousy antenna on FT8. What fun. It's super fun. Okay, moving on. So we see 5 watts, more than you think. Eaton's of Canada. So here's an excellent chart here. I think we can rotate this. Okay, beautiful. Lovely alignment chart. Don't know if I'll be doing any of this. I suspect this radio is working just fine. So probably the FM might require a little bit of adjustment, especially in the demodulator and detector area. Dummy antenna, ground lead instructions. Oh, this is for doing part of the FM alignment. Should be able to tell when we get the radio playing and tune it. We can probably get a feel for whether it's really out of whack or not. And here it is, the schematic. We finally made it. Oh, this is just the radio schematic. I was going to say, wow, what happened to half the parts? They must be on another page. Here we are, amplifier schematic. Here's the power supply. Here's where that resistor came from. Let's see if we can find it. Zoom in. I said it was right across one of the capacitors. I've already seen it. I saw it already. Right across one of the capacitors. So it's going to be... these are the capacitors here. And look, 330, 330, 330. Let's see. Let's look at how they've done this schematic here. They write the part number and then a line and then the value. Here they've gone part number, value, and voltage. Part number, value, voltage. Very good. Lots of space on the schematic too. So it's clear it's a 330. It's not a 33K. 330. So if you open a 330, if you have a 330 here and you open it, I think you'd be on your way to getting hum coming out. And why would it go open? But there's another one in the same boat here, pretty much. Not quite the same boat, similar boat. Something wrong with the resistor initially. The guy soldered it in, he held the soldering iron too long on it. And did something internally to it. Who knows? Who knows why that particular one? I think well, it could be this one, it could be this one. It's right across the terminals of the capacitor. They aren't indicating, what are they showing here? So there's a square, a triangle, two triangles. So maybe this is one capacitor. So maybe, that's a mark too. Who uses a dash to mark something? Because the dash looks like a minus sign. You're not supposed to do that. You're supposed to use these geometric shapes, like there should be a circle there. That's odd. Something odd going on here. The way they've shown this, these three lines together, that suggests that this is the can. At least it's got a square on it too. Oh my gosh, it could be any old way. Oh my gosh, there's a half circle up here. Okay, got no idea what, the physical layout of the parts in the radio can be quite different from the schematic. So not to bank too much on any of this. But it's got to be one of these. No doubt it's a 330. That's the main thing we wanted to find out. Let's take a look at how they do the power coming in. So there's the circuit breaker you dare not reach for. Receptacle for the phono motor only. And there's nothing plugged in there. I probably unplugged it and just forgot I unplugged it when I was taking things out. So here's the winding, and then we've got, there's the resistor and capacitor I was looking at. The big white one with the resistor across the 470K. They're tying one side of the power line to the chassis. Now, did I bring the plug in here? The actual, the plug is right on it. The plug is wired right into it. So let us take a look at the plug. Well, we will. We'll take a look. We're almost done here anyway. We'll take a look in a second. Push on auto. So auto is probably referring to the record player turning the whole stereo off. Whoops. That's probably what it means by that. To tuner ground. Yeah, so here's the tube heaters. I think that's what they're trying to show here. And there's many, many more of them. V1, V2. Well, they must be showing the rest. Where's the heaters? Oh, is that all there is? V1, V2. There's only two tubes on this diagram. Because this isn't the whole thing. So if we go up here, V2, 3, 4, 5. They don't show the heaters again. They are hiding. Here they are. They're over here. Here they are. So something fancy going on here. We got some kind of coils in here. Got capacitors thrown across here and there. There's no consequence to me in doing repairs really, unless there's something wrong right in here, which is almost certainly not the case. But it's just interesting things to know, to realize how they're doing things. A lot of radios, there's no coils, there's no capacitors. It's just heater strings in parallel, heaters in parallel. But again, engineers have their way with these things. Okay, we're not going to try to analyze all this. Well, let's continue analyzing this. So look, this says T4, this says T5. These are two separate cans. They have dotted lines around them. So in this radio, the AM IF is a separate set of cans from the FM IF, but they're using the same tubes. So they just haven't stuffed them in the same can. They're working the same way though, I think. Let's see. See what's reaching the grid here is coming from here and coming from here, but really it's or, because it's only one or the other that are active. So coming out of here, get through one. Well, where's this guy getting his signal? Oh. So we have FM coming in this way, and we have AM coming in from here. And the output of this first AM tube, this is the mixer tube. Holy smokes, going into here. So the AM is down here. Probably says it somewhere, and the FM is up here. Get through these four cans. There's one at the start. So this is an FM can for itself. So the first can in that string that was kind of on its own there is an FM. And so now I think we can guess. We should guess which cans are which. I have to sort all this out if I'm going to do an alignment. But for now, I just need to get a little bit in my head here. That's got to be the FM detector. See that capacitor right there? 4 microfarad 65 volt capacitor. Got to find that guy and change him out. Yeah, this capacitor is so critical to the quality of the FM sound that comes out. You need a fresh capacitor there. It's probably in good shape though in this radio. Look at that, test point K. Ooh, wow, it's all the way up to K. I didn't see any other test points, but they must be in here. Test points could be referred to in the alignment instructions or elsewhere. Yeah, I don't see anything else. Test point. How about the power supply voltage? Does that appear here? There's the two diodes, the power supply. It's really just one, isn't it? What's this one doing? $135 volts. Whoops. 260 volts. 135. Okay, I'm not sure what's happening here. Let's see what kind of voltage is coming out of the supply though. So it will be coming out here. 250. Did they write it up here anywhere? 240. 105. That's all the plate voltages are given, and then hopefully the screen voltage to 235. Good, so we can check all that stuff. We have information here to check it against. I didn't notice this before. Here's all the inputs. Mono and stereo left, stereo right. Switch type jack. microphone left and right, tape out left and right. FM stereo jacks used only on models without built-in adapter. Built-in adapter. Jacks only used on models with built-in adapter. So I guess if you had the adapter, it was such a separate unit that they built this stereo so it could literally be thrown in and plugged in. And then we'll use these two plugs. There's lots of empty plugs in this thing. So I don't think this is a stereo FM receiver as it stands. Switches which drive me nuts. Special capacitors such as temperature compensating types are identified by a note at the capacitor location. Example, foil-filled, silver mica, mica, non-polarized. What about temperature compensating? Why didn't they put probably a T, but they didn't add it there. It's just by a note. I give an example of a bunch of other notes. Can we find something with a T? This will be up in the radio somewhere, I would think. Amplifier, radio. Look for a capacitor with the, oh, see, 7.5P. Maybe that's where it goes? That's a, what is that? I don't know. I don't know. Show me a capacitor with a T on it. You know what? The oscillator, in the local oscillator, they're likely to have one. So where is that? Where's the tuning capacitor? Where am I here? AM FM tuner. So, tuning capacitor. Where are you? Huh. Here. What are you doing, Jim? Look, here, with this dotted line. So there we are. So, big tuning capacitor and its trimmer. Now, why did I want to find that? Here we are. To find the oscillator. Here's the oscillator. There's the oscillator variation here. Okay, we're looking for capacitors with a T or some kind of temperature thing going on in here. It's important to know this because if I end up changing a capacitor, I need to know if it's a temperature one. Chances of me changing one are pretty small. Lots of ones with P at the end here. Z5P. NPO. Well, I can't. NPO. Well, I'm not finding any. So we don't know how they're marking this. It could be 1, 2, 3 of them in here somewhere. Okay, we didn't find them. We don't know how they're doing it, but we know they're doing it. Oh, what's this? There we go. How come it's here? They didn't put it here. Oil, silver, mica, non. Mica silver, non-polarized. Negative, positive, 0. Negative, positive, 0. And there it is. N4700 equals temperature compensation. N4700. And the N4700, what's a 4700? Is that the value of the capacitor? Can we find, there's one, N470. Yeah, that could be a temperature one. That could be one. So, find another one that's not one. There's another N here. Here's the N47. Down here in the oscillator. for sure that's a temperature. So that, there it is, N4700. But it's a 27. Yeah. Okay, well, we'll worry about it more when we have to. Once again, I'm just trying to get kind of a light load into my head here, so I can make sense of everything else. So that, going back to that resistor, the main thing we're trying to figure out, 330 ohms. Let's stick one in there.
One leg first. This resistor is bigger than the original one. Longer. There's a chance whatever made the other one go sour will make this one go sour, but I don't think that's what happened. I think we're looking at an actual defective resistor, just left of its own accord. We can also check for heat in it too if we really get concerned. Okay, I gotta figure out the speaker situation now, and we'll operate this guy. So at a glance, there's two plugs that plug into this that go to the speakers. But a closer look, that's not what's going on. There's one that goes to the speakers and one that goes over to drive the motor on the record player. Hey, don't get those mixed up, but hard to get them mixed up. So I've got a camera shot right into here. We'll take a look at. And kind of, you know, you've got the power coming in here. And you've got an outlet right there. And then you've got this three-pronger. This is dealing with the motor on the record player. Well, I got the speaker one right up here. And actually it's hard to see because, you know, from my eye height, this is what it looks like. You don't see it. It's hidden away down there. And you're fooling around with the speaker thing. You got your fingers or whatever right next to the power. So, but it's not plugged in, so not to worry. Now, got two black wires and a yellow wire. So you kind of guess yellow is ground and black is left and right, although you usually think black is ground. Why don't we follow this yellow wire and see where it goes here. Oh, okay, I think I'm still following it. Well, it looks like it's ending right on this terminal here. This is an interesting thing happening here. Interesting terminal strip with very patterned. Look at how much of a pattern it is there. So I mean, you can pretty much divide it, you know, in the middle and go whoosh, one side's left and one side's right. I mean, you expect a left and a right to come from loose from that out of that pattern. I see. Oh, see, there's not two black wires. One is blue and the other's black. One black one goes right into the middle. The other yellow one's coming down here. You know what? It's yellow and blue with a black ground. That's what it really is. And you can see the black has an extension, so it goes to 2 posts, and the yellow and the blue go to 1 post each. That all makes perfect sense. That's where I'm going to hook up the speakers, right there. Now, one of them, luckily, my speaker has clips on it. I pick off this one, and then pick off the high one there. Ooh, looks like it's tricky to not short out. I think that's fine, but that's only one speaker. My other speaker, other speaker is just wires. Okay, so I'm gonna have to. I'll do it with clip leads. Let's do that. So although you wouldn't have known it, I was out on my deck for 10 minutes with one of my cats. Because although my videos, it would appear as if I'm just working along, I'm often stopping, going outside, going to do dishes, going off to the grocery store, and then coming back and just carrying on with the video. Once in a while it might seem like I lost my mind between segments. The camera just fades to another segment and I appear to be, what? Come from another planet? That's because I was in the grocery store a few minutes before that. So that's my excuse for sounding, for seeming to be not quite all there. Okay, so this is the other, we'll make this the other ground. Oh, connect it here. I think that's good. I think we're okay. And I'll use this red one. And we're connected on the yellow wire. You know, I can make connections over here even easier. Really, I could really do it much better over here. Okay, change of plan. Change of plan. Change of plan. Okay, first speaker. And the black wires are all coming right to this big center area here. And then we see the blue signal wire right on the end. Like that. And then we'll do the same with this guy. Black into the grounding area. These clip leads have a way of walking around, jumping off. Jump off and into the radio. I don't want that to happen. And make sure they're clipped pretty solid. And then this can short. If I lay the receiver down, it's going to knock those clips around. I don't want to do that, so we're just going to look at it sideways. Better view of the smoke and fire coming out of here too. But I don't think there's going to be any smoke and fire. So we're going to go with no antenna, no knobs. Oh boy. I'm going to stop and put knobs on this radio before I get into trouble. Okay, knobs on. Brought the panel in because it's got the writing about what each of these knobs is, and here's that record center. Unfortunately, it's broken. So, too bad. Never seen a blue one. They've all been yellow in my life. This is the plastic cover sheet. I think when we clean that up, all those marks will disappear. And then here's the panel that's been protected. So we have treble, bass, pull on, pull off on the treble, bass, push off automatic. So when you have it pushed off, it's also in the automatic setting where the record player will control the power. I believe that's what's going on there. Treble, bass, level balance. There's the balance adjustment here, the pointer, and then the level. So I'm going to turn way down. And these two are stuck together here. And it shouldn't do that, I don't think. Shouldn't the balance just be sitting? Could be, you know what? Could be you adjust the balance a little bit, and then from then on, that's created an equal balance in the speaker. So this is a compensator for bad balance. it would say, something like that. Selector. Okay, here we are. Tape, phono, AM, FM, FMS. FM stereo. And tuning. Let's see. Oh, I broke it. I broke it. Put these on a little better. Okay. That's the rundown on the controls. Which one's the volume control, Jim? Tone, volume. Volume down. And to start, we want to know we're on the broadcast band. So I go FM, AM. So that's a broadcast band. Speakers connected. Ready to go here. So now I'm powering these things up. Again, if you're watching my video for the first time I power something up, I want to try to limit the potential for something really bad happening, and I don't want to use my house circuit breaker. So what I have overkill in this respect. I used to rely on something called dim bulbs, a dim bulb system. And there's the two light bulbs. And the idea is the power you're feeding to the thing you're working on is passing through those light bulbs. Now those are old incandescent light bulbs, like big resistors basically, and they light up when they get busy. So the deal is, plug something in, turn it on, the power coming to here is going through those light bulbs. If this thing has a short circuit in it, all that happens is the light bulbs come on full and stay that way. And then I know, oh, there's something really seriously wrong here. Thank God I didn't just plug it in the wall, because my wife would be asking, why did the lights go out? So that's the whole idea of the dim bulb system. I have a switch panel up here. I can engage the dim bulbs or bypass them for full power. Then more recently, I acquired this guy, which is a much more common way of controlling power on a shop bench. But I actually find it much more clumsy, although it's a better instrument. It's an instrument, it's not a light bulb. Got a meter on it, tells you different things. I really like the dim bulb system, mostly because if you're getting into trouble, the lights are blasting you in the face. So, see, I have two lights so I can control how much I'm using in here. For a radio like this, this guy's not going to draw a lot of power. So I typically restrict it with, I'm going to restrict it with two lights here. Two bulbs are screwed in. They're different wattages, that's why I have them, so I have some flexibility there. That's the dim bulb system. The power ends up here. And remember I said something about overkill? So this guy, this is a great little device. You can buy these on the internet for not much money. There's all kinds of them. And it just tells you the power and other factors on whatever you plug in here. So you plug in your vacuum cleaner and you can find out how much power the vacuum cleaner is really pulling on there. So I have it. I'm going to use it. So this is going to also tell me, it's going to tell me initially the voltage that's arriving at the plug here, at the plug for the guy, because the voltage, some of it will be lost in the light bulbs. Okay, once again, volume is down, and the switch is off. The switch is off, or in automatic position. I think we're ready. I don't think there's any reason to hesitate now. So, okay, that arms my system there. I just threw the main switch. Makes this little light come on. Overkill. Overkill. Oh, there's even more behind this. I'm not gonna, like, there's a meter here. More stuff. Overkill galore. Here we go. Watching the lights. Nothing happened. That's really good, because the unit is switched off. So now I'm gonna cut the power off. Switch the unit on. I really shouldn't be this, don't really need to be this careful. So this time I'll switch the power on and the light is going to come on. It's going to probably come on fairly bright at first and then dull down, maybe even disappear. Here we go. Those were bright. It's dulling down, and then it should start brightening up again once it gets down, way down. 98 volts on the radio. It should start coming up again. Come up. It's starting to come up. And it's not going to come up very far. Oh, it's coming up a little bit. 100 volts. So what's happening there is, at first, all that's happening in the receiver is the heaters are heating up on the tubes, but the tubes can't operate until the heaters get fully heated. Once the heaters are fully heated, something coming out of the speaker there, then the tubes start drawing current and the whole thing gets going. And the extra current lights the bulb up a little more. So currently we're running it with 90 volts, just a little low. Let's see what we can get out of it. That's not the volume, Jim. That's the tone. Here's the volume. Sounds like a radio. So we're going to give it the full voltage now. That's a bad sign. Okay, so this is a very, 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 very bad sign. Very, very bad sign. So I'm going to cut the power off and talk about what is going on here. So this is the vintage of receiver that could have a very difficult problem in it. Unfortunately, the problem makes the sound of static lightning type crashes, just like what you heard. Kind of a random crashy, sparky sort of sound. And I'm jumping here to conclusions, so I'm not concluding this, I'm just jumping. It's possible that inside these cans are failed capacitors. We saw in the parts list it mentioned silver mica capacitors. Didn't say much about where they were. We're going to have to look into this. Silver mica capacitors, as built inside these cans, tend to degrade and they begin to fail and short out. And the shorting out is that crackling sound. It's a major hassle to sort this out. Could just be one. Could be all of them. Could be nothing to do with these. Could be nothing to do with the problem I just described, silver mica. Could be so many different things. Could be a tube. A tube can sound like that. Oh my gosh. That's not what we wanted to hear at all. So I'm going to turn it back on now. We're going to play around with turning it radio, this, that, the other thing, and see when this sound comes and goes. In itself, it's not injurious. Having it operate with that clicking in that is not going to hurt the radio any. It's just going to hurt my, it's going to hurt me. Let's bring it on again. I just did the dim bulb thing. All fine. Okay, so now those capacitors in those cans have to do with the radio only. So if I flip this guy to phono and that sound disappears, that's just one more nail heading for the coffin here. Oh, that sounds good. How come it's different? Now that's just interference. What changed? You got 116 volts on the outlet, which is normal. What happened? I fixed it. That's what happened. I fixed it already. Okay. We're on AM. Let's see what we can pick up with this radio. Oh, that's a strange thing. I'm sure I heard that. Now it's gone. Welcome to the world of radio repair. These radios do have a mind of their own. So we're up around 140. There's nothing up here to pick up. Middle of the day. Lovely gold pointer. Like it. Very nice. Get something down around here. Nope. 680. 640. Spaceship. 590. Getting quiet. Gone quiet. Well, and somebody's shaving. So it's picked up nothing, but that's could be because of the position of the antenna. And we're in my shop here. These are bad things. So I'm going to give it a bit of a boost, antenna-wise. I'm going to try. Okay, I got a couple things to do, so I'll just stop recording and get them done. We'll see. Okay, so here's the somewhat crazy thing I'm going to try. This goes out to an outdoor antenna of some significance. I'm going to clip it to this loop, and then I'm going to hang this loop right near the antenna of the radio. Okay, the antenna's back there. We got something. Now we'll see if we can pick up something. Down, around, down, around. Oh, that's great. So this is the French station. Very good. 740. 680. 640. Spaceship. 590.
We'll get back to the NBA. What's the perfect number for the playoffs? Because I think parity is a false wish.
Okay, now we'll try the FM receiver. We need to put some kind of antenna on it, or it's not a fair test at all. So in the back here, where it's hanging up, it's hanging over here. I'm just going to put a single wire on the FM antenna. It's nothing but a piece of wire, and I'm going to hang it up here where everything will interfere with it too. We'll see. We'll see how this goes. Hang there. Okay, it's really a terrible arrangement, but let's see what we get out of it. Volume. And we want to switch to FM, so it was FM stereo. So that's FM. Volume. I have to turn it awfully high to get the hiss. Is that just because of the antenna? Tune it around. Now, while I'm doing this, I have to be careful of copyright hits, so I can play music for maybe 4 or 5 seconds, but not much more than that. So 91.5 down here. This is where I hang out. And that might have been 91.5 we heard up here. Okay, so I got a radio here with 91.5 on it.
Whenever I need advice, whenever
That's
I need
what
to
it
be
is.
cared for.
Somebody talking. That's what we're looking for. We're looking for somebody talking. Should be right here. 88, 92. I guess it's a dash mark. So see, there's a dash right there. A similar dash there. That's probably marking the position the pointer should be in when you're maxed out this way. It's a little bit past it. This is probably an alignment tick. You put it there, do some kind of alignment process. That's my guess, because they're using circular dots to mark the numbers. So the dash is probably a secret alignment mark.
Coldplay, higher power.
Nothing really wrong with this radio, is there? Starting to conclude, hey, there's a lot of work here. Well, I found a bad resistor. Yay! But, really, am I going to find anything else wrong with this? Could do some voltage checks. Should do voltage checks, screen and plate on the tubes, and not much else than that. Wow, that's great. Yeah, you could go in and start changing these capacitors that you're suspicious of, but there's no reason. There's no reason. Okay, voltage checks, eh? Okay, lucky me. The schematic shows 2 pin numbers and the voltage that should be on the pin if the pin is significant, like a plate or a screen. Voltages, they don't say what kind of meter they use, because by the time, this era, there was no need to warn people. But what's the action? What happened? What happened there? Am I seeing things? Did this volume just jump up on its own? What happened there? Strange stuff. I don't know. What the heck happened? But don't worry, I can still fix this. Okay, so first we want to see the power supply voltage. So we'll go right down where that resistor is that I changed. And we'll see what kind of voltages we get there. What am I doing? I'm looking. What are you doing? You've got to keep an eye on this meter over here now, which I need to turn on. I'm not going to get anywhere without it on. So this meter is ready to read 500 volts here. It's just warming up there. So it's 500 volts here. So we're expecting 250. We're expecting it to go pretty much straight up and down on this reading. No, that's not straight up and down, is it? Now, maybe I'm not on the highest voltage area. The transformer's over there. It's way low. Definitely on a 500. So we're reading 125 here. The power supply, let me look at the schematic myself quickly. So there's a power supply of 135 and another of 160. 160 past these diodes here. So if I think this is, that's very low. So there's 250 finally. So there is a 250 in here. Other side of that great big resistor. There we are, 250. Okay, so we know the full voltage is available at the power supply. Now we'll go around the tubes and find out what's there. This is a bit of a difficult process here. We'll start with the 2 output tubes. They're right there. 2 output tubes, and so that's a 6 GW8. 2 6 GW8s. And we should look on pin 6, 9, 3, 1. 1, 3, 6, and 9 should all have voltage on each tube. For the gap, there it is. 1. This I think is 1. Nothing. Okay, so I may have got it wrong. That might have been 2. This would be 1. Nothing. The radio works, so we really expect all these readings to be correct. Is that not 1? It really looks like 1. Wasn't 1, 3, 6, and 9? 1. 2, 3. 4, 5, 6. 7, 8, 9. So pin 9 has 100 volts on it. Pin 9 should have 100 volts on it. The pin 1, oh, I was wrong about 1. 1 is only supposed to have 120 millivolts. So, okay, 1 was a grid, that's why when I touched it we could hear it. So I was just wrong about that.
There's only one, yeah. So it's really 3, 6, and 9, they're all there.
3, 6, and 9 on the other tube now. So they put these tubes in exactly the same way. I think they did. So 1, 2, 3. 1, 2, 3. 4, 5, 6. 7, 8, and 9. 9's the 100. Good. That's good.
That's good on the output tube. We should look at the grids. The grids are pins 1 and 8. They should have. We should do this a different way. These tubes have. What? They have 4 cathodes in this tube. That looks like there's 4 cathodes in this tube. 6GW8. Can't say I've ever really worked on a 6GW8 before. 4 cathodes. Four complete tubes in one. Okay, I guess so. So looking down, looking at the grids then. 1, 8, 1 and 8. Just 1 and 8 on each tube. What we're worried about here is excess positive voltage. What we want to see, make my meter more sensitive, there's no movement here. Let's see if this works out. So pin 1, here. Now it's moving backwards. That's fine. You know, I'm going to flip my meter. A negative movement will go up. That's what we want to see. Up. We want to see up on 1. Just a little bit, and 8. 8 would be. Nothing at all. Is that really 8? Nothing there. Now we'll go 1 and 8. Wait a minute. How many pins are in this tube? 8. Count them again. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 1 and 8 on the other tube. 1. Similar reading. And 8. Same nothing. 9's got a big positive voltage on it, and 9 is 9 was this. It was a plate, for crying out loud. Okay, that's good. So no positive voltage floating on the grids of the output tube. It's just proving the quality of these capacitors somewhere in here. What's that Hunts guy right there? What's he up to? Wouldn't there be? There's only one. Wouldn't there be another one down here? Don't see it. Don't know what he's up to. No voltage on it. Okay, we got a bunch more tubes to look at. The primary one is the output tube. So, what's next here? And where are we on the? Oh my gosh, it's almost 11 o'clock this morning. I got too much video shot here. You know what we'll do? Maybe we'll leave it at this. We know it's safe to operate. We know the output tubes are not stressed. So there's no urgency. I don't see any smoke, flames, fire, nothing screaming. I don't hear fire trucks coming, so I think we're good on this guy. Tomorrow I will finish off these voltage tests. Now I'm going to stop the camera and finish them right now and then tell you the result. That's what I'm going to do. A lot of effort, nothing out of the ordinary at all. So good. It's in great shape. That's really what it is. Just one resistor. The consequences of which I'm not even sure. And that funny sparky sound which has not reoccurred. Great. Next record player tomorrow. Thanks for watching.